All right, so part 2, expression add operators. We'll take a look here. I deleted. I started the video a moment ago and then I deleted it because I realized I made a mistake. I technically doxed myself, which I do that from time to time. I shouldn't keep doing that, but I do that. So read the question. I don't have a lot of time. I'm just going to try to attempt to solve it here, update sort of the mistakes I made before. We'll read the question again quickly. Expression add operator is given a string num that contains only digits and integer target. Return all possibilities to insert the binary operators plus, minus, and or multiplication between the digits of num so that the resultant expression evaluates the target value. Note that operands in the returned expression should not contain leading zeros. So, one modification we made before. So, a couple things. One, we were saying, we need to do something about the leading terms, right? So you can't lead with a 0. Another issue was we were saying, we have to go right to left instead of left to right because if you go left to right, then it's as if you have parentheses on all the right expressions when meanwhile, if you're doing addition and subtraction, it's actually, those would actually process the left to right. So if we're going top down, it means you actually need to go sort of top down, right to left, ends up making you go left to right, which is kind of peculiar, but that's what we got to do. So we've got to update this to do that. So we're going to go in the reverse direction. So this index is actually going to go from the right to the left rather than the left to right. That's the first change. Second change we need to address is handling multiplication, because multiplication has a higher precedence than addition and subtraction. When you start mixing and matching addition, subtraction, and multiplication, you run into some problems because the multiplication might happen at the wrong time. It might happen either after an addition when it was supposed to happen before, or it might happen, well actually yeah, that's actually really it. So it might happen after when it was supposed to always come before. So that's the issue. Another idea is actually just to generate all of the sequences themselves without actually calculating the values and then just running through the expressions at the end. I mean, there's no parentheses. We could just calculate the expressions with just addition, subtraction, and multiplication. You could just build an expression tree out of the string and then process the tree. I mean, that's another idea. We could actually just process each string, just build each string and then process them one at a time. We could do it all in one shot though. I think it's fine to do it one piece. So let's reverse the direction first. So first things first, a is less than 0. A is going to go from right to left. Let's do that. The other issue, actually, the second before I do it, there was an issue of how do we handle the multiplication? Though the idea that I had was that we could just have the previous value that we see, we're going to return that as well. So our tuple will have a few different pieces of information. It'll be the current value, which is the long, a Boolean for the operation, addition, or subtraction, would be so the previous operation that's not a multiplication, which we could say here, we could just say addition's false, and then these are really bools. We could use an enum for this too, but it's actually, I think it's a little more efficient to use a Boolean. Addition, subtraction, and you could do long, Boolean, and the previous value, which is also another long. So now you have 4 elements in each tuple. So now what we're going to want to do is reverse the direction here. So you're going to actually start from A, and you're going to go to the right, or to the other side, to the left rather, decrementing I. And you're going to say, one of the issues here is the integer that you create. We're going to have a power of 10. And this could be a long, I think. Yeah, it needs to be a long actually. And we're going to say it starts off at 1, and you're going to increment by a factor of 10 each time. And we're going to use that to add the digits to build our integer, not our integer, our current value. Yeah, so these are going to be, and all of these could really be over here, I think. And you want to move I out here because you want to, yeah. So you can move P inside here as well. Current needs to be on the outside though. Yeah, okay, we'll just leave both of them out there. Both of them out there, it's fine. So now current is going to be itself. So plus P times this value, right? So you get the character. If P is 1 initially, current is 0. Current goes to 0 plus this. So plus equals we can do. Yeah, each step. And then the next step over, we would say, how are we doing? The next step over, we would say P multiplies by 10, and you're now the next position is what we're going to add to current. So you keep doing this. So you do that right to left, and now here's one issue. Temp is the string. Now, if the character, if C is a leading 0, so now we just put that in the front. So you can have 0, but you can't have 0 in front of something else. So it's only if, so here you have if C is 0 and temp is not an empty string. In other words, you've already processed something. A 0 you can't have a leading 0. You're going to increment I and break. So if I is greater than 0 or I is equal to 0, if you make it all the way down, then that means you've made it all the way through, and you could potentially use just that as a result, just that single value. But if you didn't make it all the way down, then you can't use that. Yeah. So if you have C is 0, then it's going to be a leading 0, and it's a leading 0. Then we break there, right? So let's change it slightly. So you add the character. Now what's tricky here is this actually, it's going to go on the other side now. So it looks like this. So now we're building our string in sort of reverse order, which is a little bit awkward. I don't know if that's good if we want to do it that way, but I think it's okay. Hopefully this is okay. I hope this isn't too expensive to do it this way. We have our recursion is the same. Now it's I minus 1, right? You go one more character to the left. All those possibilities. And now our tuple is going to be backwards here. So we have a few things to add. So now we have the current value, the type, sort of like previous type, and initially it's going to be a Boolean, by the way, or yeah, addition should be. Yeah, the previous we can just say 0, 0 addition. It could be just 0, 0 addition, 0, and what's the last thing? The string at the end is just an empty string. That should be fine. So you have previous type and previous value. And what you're going to do is, in different cases, you're going to do different things. So in the first case, we're going to say constant For multiplication, we want, actually you could just put all these directly in there, I think. You may just want like auto T. Maybe, I don't want to do this. I'm not entirely sure. Also, it's going to be the other way around. It's going to be, because we're going left to right, it's going to be S is on the left side, temp is on the right side. Same deal. So those get reversed. Also, you're not going to immediately set up your current value. What you're going to do is when you multiply, your value doesn't change. But now what happens is the previous type stays the same, and this previous value gets multiplied by current. That's how you handle that part. When you're adding, though, now you're going to update. You're going to actually process the previous routine. So you can do const int new val is going to be previous type, depending on which one that is. So you could process this. So we get new val is going to be, could start off as just the value, and then you can say it's not really previous value, it's like it's more like an iterating value. I don't know how you express it, like a it's just like a rolling value, something like that. If previous type is equal to addition, then we're gonna set the new value plus equals previous value. Otherwise, right, it would be if previous type is subtraction, and new value is going to be remove the previous value. So what this means is that as you move from right to left, or really it's going to be left to right, what's going to happen is there is a previous addition or subtraction that we didn't calculate yet. And what we're doing is we're collecting multiplicative terms until we process that addition or subtraction. So that when we process that addition or subtraction, if there were a series of multiplicative terms that we saw in a row, that would all be gathered up into one number, and then we would apply the addition or subtraction. So the number that's being gathered up into is the previous value, that rolling number, and the previous type is the operation that came before this sequence of multiplicative terms, and the value before that operand is what we call val. So there's val, previous type of operation, and previous value, which again, I realize is a little confusing. I probably could come up with better terms for these things, but this should work theoretically. So our new value we just initialize as val, and then depending on addition or subtraction, we add or subtract the this previous value. And then that's going to be what we use for processing addition and subtraction. So we can do our current. Now we actually don't apply the current value yet. So that's an interesting kind of point. What we do is we say applying the current value is going to do what? We want to do what? The previous value stays the same for for addition and subtraction we would update, right? So now we have our new val for both of these, and the previous type is then set to addition. So previous val is going to be addition, and the new previous val is actually going to be current. And now we added an addition symbol. Yes. So now we do the same over here, except with a subtraction. Yeah, so this is pretty involved. It's kind of involved. Not too bad. Small changes that we can make, but I think works if we do it this way. I don't know if this is what we need though. I don't know if this really makes sense, but we could try it. And so at the end here, when we calculate V, so we have V, we have S, and we have two other things. We have previous type again, and previous val again in the result. And what we're going to say is we're actually going to calculate these values again. So we're going to say, now the deal is basically you're always going to have a previous addition or subtraction, even if it's a sequence of all multiplications, because we always have in the base an addition in there. We just add a 0, which should give us identity. So we can always process this new value. So it's always just going to be V, and then new value equals V, and then plus equals previous value. Oh, this is a constant, by the way. That's a mistake. Yeah. Depending on the type, update our new val. Let me say if new val is equal to target, then we're going to push back S. And notice we don't, for this last addition or subtraction, whatever is at the end, we don't add a symbol for that. So something like this ought to work. I think it actually works. It doesn't just compile. Okay, it doesn't compile. Of course. I guess I need to make it oh no, I'm sorry. That's why. That makes sense. I need to do this. A little bit confusing. Can I do that? Do I need a... I don't know. Does that work? Let's find out. Nope. It's almost always going to be, there is almost always going to be some kind of issue with regard to right. Oh, so I forgot. Yeah. So this is the only scenario where you don't have any kind of well, you could just do addition. Actually, that works. That's fine. This would be, what's temp? Temp is just the whole, yeah. So in this scenario, this is when you have the 300 milliseconds, huh? I just noticed that. I don't know. I don't really look at too much at like what's in OBS, what to do with OBS. But anyway, so this is kind of a nifty thing. So this is the case when you don't have any operations at all. You could still add 0. That's fine. Your current and temp, both, this is the string representing the whole number, and this is the number itself. And this should work. Let's see if it compiles. There's probably some other error in there that I didn't think about. Okay, so output 0. Nice. Really? Okay, wasn't expecting that. Oh, that's why. Duh. We gotta go from the other side now. Num.size -1. Yeah, that's probably. Let's see. Does it compile? Does it have runtime error? Let's see. Wrong. Wrong answer. Wrong answer. Okay. Well, not perfect. We have these extra addition symbols in there, which I wasn't expecting. At least these are correct. These two. But what's this one over here? What's going on there? What happened? Oh, that makes sense. Okay. Oh, I see. Yeah, because we're adding, and we're going right to left, so we're adding this extra symbol. Okay, but this actually shouldn't be correct. This one, the 6. I don't know where that came from. 6 + 1. How did that happen? How did that happen? That's not supposed to happen. Interesting. A few things. So I guess we could just check if temp is not empty, then we add a symbol. Otherwise, we don't add a symbol. That's probably what I'm missing here. Also, again, kind of confusing because we're building things left to right. Yeah. Okay. Huh. Times 1 plus 2 times 3. Oh, that's another issue. If you're multiplying by 0 by 1, I didn't think about that. Adding and subtracting 0, but multiplying by 0 doesn't work. I didn't think about that. That's awkward. I didn't consider that. That's why this one's showing up. So we could fix the extra symbol by just not creating these strings when temp is empty. That's fine. However, one, I don't want to have 3 if statements in here if I don't need to, and 2, have kind of an issue if we consider this always to be 0 or 1. If we put a 1 here, it doesn't work for subtraction and addition. If we put a 0 here, it doesn't work for multiplication, the calculation at the end. Because what it'll do is it'll consider this factor to be 0 times 1 that we're adding on the left side, which is not correct. What we want to do is, how are we doing on time? 20 minutes. What we want to do, maybe we can make this empty. What if this is just empty? How about that? Can we do that? What do we end up putting here? Oh, we put no, but this basically is the base case here. This doesn't really matter. You kind of never reach. You just skip this. This is the other base case. Second base case. It's like a secondary base case. This really is the base case. But you don't want to add 0. Because if you... actually, what happens if we do this? Let's find out. Let's see if it goes away. It might go away. I don't think so. Everything goes away. Interesting. Oh, actually, it's got to be -1. Okay. Slight error here. Alright. Now we lose 1, 2, 3 though. What happened? Oh, okay, that handles this. Alright, that's fine. So everything will have a something in it. But then now we have the problem of what happened to 1, 2, 3. So we put, yeah, because now you have 0 times 1 times 2 times 3, which is not what we want. I guess I do have to use an enum and just make it null or something. Addition, subtraction, and null. Alright, we'll use an enum. I don't really like to use enums if I could use bools, but it's fine. I probably should be using enums in the future, really. So enum is just going to be operator, or just oper, ABC. Okay, looks like anything I put in here is going to operation. We can do operation enum, and we can say addition, subtraction, and we'll just say, let's call this none. So the tricky thing about not having an operation, we still want to have a rolling value to collect multiplications, But I guess if it's a none, you just don't apply the value there. Yeah, that's interesting. Yeah, it's tricky. I mean, you can do something kind of clever here where you don't really have an enum, but you could just say if it's a 0, you could use a 1. No, you don't want to do that though. No, don't want to do that. You want to know if it's a none. That's when if it's none over here. So part of the problem is when you multiply, right? Because if we put a 1 or a 0, this previous value we're assuming is an accumulating value. If it's a 1, so we could say constant rolling number or new num next val or something. I don't know. Let's call it t. It's previous value, right? So depending on the type, yeah, all right. So this gets confusing, but we could do addition, subtraction, and none. If the previous operation is none, then the rolling value we want to use is a 1 here rather than a 0. That's kind of the tricky thing. Otherwise, use a 0 over here for the rolling. Actually, you're overwriting the rolling value here anyway. So actually, you really don't want. Maybe you just use 1 instead of addition. But the problem is that you have addition here, and you'll process this addition at the end. Yeah, so they're always going to be off by 1. I guess you subtract 1 always. No, that doesn't make sense. We should do this quote unquote properly. So addition, subtraction, and none for enum. And I think you do make it a class too if you wanted to. Forget what the deal is with C++ enums. That's really what it was. I didn't want to look up what an enum does, or I didn't want to look up enums again, because I've looked at this page like 30 times. My lifetime, probably more than that. Excuse me, I always forget. And not always, but I tend to forget. Unscoped enum. So enum color. There's like a enum struct, yes, scoped enum. What is the difference between unscoped and scoped enum? Real quick. Unscoped enumeration. Enum, name, optional, enumerator, const expression, enumerator, const expression, enum, name, optional, type. As a type, I don't know what the type means in C++. Enumerator, const expression, enumerator, const expression, enum, name, type in C++. So you can have these or not. Declares an unscoped enumeration type whose underlying type is not fixed. In this case, the underlying type is an implementation-defined integral type that can represent all enumerator values. This type is not larger than int, unless the value of an enumerator cannot fit in an int or unsigned int. If the enumerator list is empty, the underlying type is as if the enumeration had a single enumerator with value 0. Okay, so here, unscoped will give you integers, right? Unscoped enumeration type whose underlying type is fixed. So it should be an integral type, I believe. Opaque enum declaration for an unscoped enumeration must specify the name and the underlying type. I'm not sure what an opaque enum declaration is, though. I don't know what that does if it's opaque. Each enumerator becomes a named constant of the enumeration's type. That is, name visible in the enclosing scope and can be used whenever constants are required. So enum color, red, green, blue. These are basically integers. Switch on R, red, green, blue, and yeah, color equals R equals red, so it should print red. Each enumerator is associated with the value of the underlying type. When initializers are provided in the enumerator list, the values of enumerators are defined by those initializers. If the first enumerator does not have an initializer, the associated value is 0. For any other enumerator whose definition does not have an initializer, the associated value is the value of the previous enumerator plus 1. Okay, so 0, 1, 10, 11, 1, 2, and then this is 12. Oh, C is 10, yeah, okay, whoa. Values of unscoped enumeration type are implicitly convertible to integral types. If the underlying type is not fixed, the value is convertible to the first type from the following list, able to hold their entire value range. Okay, so this is what you'll end up with if you can't fit it. I don't know what long, I don't think longs are necessarily longer than longs, by the way, typically not. I guess depends on the compiler and the operating system. Extended integer types with higher conversion rank and rank order signed given preference over unsigned. If the underlying type is fixed, the values can be converted to the underlying type, preferred in overload resolution, which can then be promoted. Implicit conversion. Okay. Color, red, yellow, green, blue. Red is 1, and equals blue is 21. Okay, interesting. Values of integer, floating point, and enumeration types can be converted by static cast or explicit cast to any enumeration type. If the underlying type is not fixed and the source value is out of range, the result is unspecified until the behavior is defined. Interesting. Unspecified until C++17 and undefined. Unspecified, undefined. Okay. I'm not sure what the difference is between unspecified and undefined, but okay, fair enough. Source value is converted to the enumeration's underlying type is floating point, is in range if it would fit in the smallest bit field large enough to hold all enumerators of the target enumeration. Otherwise, the result is the same as the result of implicit conversion to the underlying type. Note that the value after such conversion may not necessarily equal any of the named enumerators defined for the enumeration. Huh. Interesting. So if you cast this to 7, what is going on there? Look at this. A lot going on there. So we static cast 7 to an access T, which doesn't exist. You know, the range is 0 to 7. So RWE and read, RWE and write. So this assertion should fail, right? Undefined behavior since C++17, undefined behavior since C++17. So how come the range is only at 7? I guess that's because, oh, it's literally the smallest integer. So it's an integral number that's just tiny. So it's not necessarily tiny. Yeah, I see. I think I understand. So these aren't bits, these are bytes. I mean, it's not even bytes. These are 3 bits, I think, right? It's not very, it's a very small type. The name of an unscoped enumeration may be omitted. Such declarations only introduces the enumerators into the enclosing scope. That's interesting. What kind of an enum is it? I guess you just, the enumerators themselves are constants then? Defines these things. Okay, that's interesting. Range 0 to uint max. Foo -1 undefined behaviors in C++17. Even if foo's underlying type is unsigned. Oh, that's interesting. Even if it had a type. Okay. Unscoped enumeration is a class member. Its enumerators may be accessed using class member access operators dot and the arrow. Direction left, right, struct. Oh, okay, neat. So you can make an unscoped enumeration a class member and access the class members. Oh, that's kind of neat. So it can actually be accessed even with the object itself, pointer and X. Okay, that's useful. Scoped enumerations. Okay. So enum class declares a scoped enumeration type whose underlying type is int. The keywords class and struct are exactly equivalent. It declares a scoped enumeration type whose underlying type is type. That's the second one. Opaque enum declaration for a scoped enumeration whose underlying type is int. Underlying type is int. And you can also specify the type with an opaque enumeration for a scoped enumeration whose underlying type is type. Enum struct name type or enum class name type. Each enumerator becomes a named constant of the enumeration's type, that is name, which is contained within the scope of the enumeration and can be accessed using scope resolution operator. There are no implicit conversions from the values of a scoped enumerator to integral types, although static cast may be used to obtain the numeric value of the enumerator. Each enumerator becomes a named constant. Each enumerator becomes a named constant of the enumeration's type. That is name. Okay. Enumerations type. Okay. That's so confusing. Which is contained within the scope of the enumeration and can be accessed using scope resolution operator. There are no implicit conversions from the values of a scoped enumerator to integral types, although static cast may be used to obtain the numeric value of the enumerator. Oh, so scoped enumerations and unscoped enumerations behave differently in based off of like conversion rules. Okay, I think I understand the underlying type of what you're using. Okay, so you have to scope. I see. So scoped enumerations and unscoped enumerations. Okay, I like unscoped enumerations. So I guess that's why they call it scoped and unscoped, is that you give it, and these are of type color, each of these. They're not integers anymore, whereas the other unscoped, they're just integers. Okay, I think I get it now. All right. I don't think I took the time to read this in the past. Like, I think I just never read this. First time reading it, which is not great on my part. Not good that I did not read this. It's important to read. It's important to read, man. I don't know. Sometimes you just don't have the time, you know, for whatever reason. Okay. Each enumerator becomes a named constant of the enumerations type that is name, which is contained within the scope of the enumeration and can be accessed using scope resolution operator. There are no implicit conversions from the values of a scoped enumerator to integral types, although static cast may be used to obtain the numeric value of the enumerator. All right, sweet. Error, no implicit conversion from scoped enum to list, and this is okay. An enumeration can be initialized from an integer without a cast using list initialization if all of the following are true. The initialization is direct list initialization. The initializer list has only a single element. The enumeration is either scoped or unscoped with underlying type fixed. The conversion is non-narrowing. This makes it possible to introduce new integer types, safe-int, that enjoy the same existing calling conventions as their underlying integer types, even on ABIs that penalize passing and returning structures by value. Okay. Don't really know what they're talking about here. I feel like I would need to read that again later, another time. And since C++ 17, this is the case. So you can initialize from an integer without a cast using list initialization. And I have some examples. So byte is a new integer type. Byte B, okay, as a C++ 17. Direct list initialization. Error, okay, same value as B. Error. So you can't do this one because conversion is non-narrowing. I think that's why. I don't actually know. Scoped or unscoped with an underlying type fixed. So we fixed it to a byte. Oh, okay. Well, a byte is, I didn't know you had bytes in C++. Oh. Oh, it exists in C++ 17. Okay, well, for the most part, the compilers that I see are C++ 11. They're usually not C++ 17, but this is nice. Like char, unsigned char can be used to access raw memory occupied by the other objects, object representation, but unlike those types, it's not a character type and it is not an arithmetic type. A byte is only a collection of bits, and the only operations defined on it for it are the bitwise ones. Oh, that's interesting. Okay. Dude, that was like 4 years ago. Excuse me, they were working on it like 5 years ago, 6 years ago. Usually it's like a year or two before the standard comes out. That's what they were working on before they release it. Okay, so interesting. So you have bytes. So this is an error, I guess, because the bytes, you can't get negative numbers with a byte. Maybe that's why. I'm not sure what non-narrowing means exactly. I think, oh, okay. Excuse me, without a cast. So I guess because you need to cast this, that's probably why it won't work without it. It has to be something you don't need to cast. A byte I think has 8 bits, so 2 to the 7th is definitely larger than, is it 8 times 8? Yeah, it's larger than 42. Okay, so error, copylist initialization of a constructor parameter. Oh, I gotta go. Uh-oh. Okay, as a C++17. So you can initialize a byte here, and there's a struct with the byte. You can initialize the struct. See, this won't work. Copylist initialization of a constructor parameter. Okay. It can't be copylist initialization. It's got to be direct list initialization. That's interesting. So this is copylist initialization. Copylist initialization of a function parameter. No good. It's got to be direct list initialization. Handle, whoa. Whoa! Oh, it's a fixed width, okay. Excuse me. So invalid equals 0. Unsigned in 32. Handle classes. So this is scoped. You can say handle H of 42 is okay. That's interesting. And then using enum declaration. All right, there's probably more to read about enums, but we're going to skip it for now. We can come back and read these things later. So that's interesting. And then you have other things like, is a scoped enum, is an enum, underlying type of the enum, to underlying, oh, it converts an enum. Wow. All right. So it's good to review enumeration. So we want unscoped, because we just want to dump these right in there. Addition, subtraction, and none. I don't know. Can we have access to these things? We may not actually need to include references to this unscoped enum. I wonder. I don't know. I don't know how that works. But anyway, so yeah, these are going to be enums now, operation enums. So we have long. Oh, maybe I do need to say what it is then. All right, that's fine. We'll scope it. How do I include that in the scope here, though? I don't know. Can I do that? Call it an operation. I don't know. We'll find out. We'll find out soon enough. Operation. Classes, I tend to prefer to capitalize classes. So we have an operation. I gotta go though. I gotta leave. I got to go, man. I got to go. With the previous op, no. What are we thinking here exactly? Not a Boolean anymore, but operation. Okay, alrighty. So no longer addition subtraction. We're gonna have operation. Previous op, previous value, previous op, previous value. Yeah, so this is going to be operate, so it's scoped, right? Operation addition. And then, okay, can we put that here? Yeah, that's fine. And this is going to be operation subtraction. Okay, because now we can have another thing here. And there's an operation none. Then we can set this to a 1. That's actually another question. I don't know if that works either, by the way. Like I'm thinking about it now. This might be wrong. If there's no operation, problem with that too is we don't necessarily want to add or subtract an extra value. So the previous operation is just none multiple times. Then this part this multiplication should still work. But the problem is that we don't know. We can't figure out like I have to get going too. Oh no. Maybe I'll just make this movie and just cut it short. The problem we're going to run into is we can't just multiply by 1 every time, right? If we set this previous value, if the previous value is a 0 and the previous operation is a none, then we can set this to 1. The problem with that though is that there could be a 0 somewhere in your solution, and the previous value is therefore 0 at some point, and the previous operation could be none because it could just be nothing but multiplications, right? And then you have a spot where the logic fails. No. All right, so we gotta sit and think about it for a while, huh? How do we not multiply by 1 every time we see a none? Well, I guess we could just write a third state in here and just call it multiplication. And then we could do it that way. So if it's, depending on the previous operation, we either multiply by 1 or, so we could say t is previous value, and we say if previous op is equal to multiplication. Multiply. Should do add, subtract, and multiply. That's better. Don't need these to be so. Yeah. Need so many characters here. Oh. I gotta go. Alright, the previous operation is to multiply. They're going to update t to previous value times current. Or we're going to times equals current. You can actually set it to current. And then if it's multiply, then you multiply by previous value. Otherwise, it's just current, right? It's just current times 1. So yeah, so this is always going to be t. Previous operation, actually, this one gets updated too. Now here's the problem. This is wrong too. No. This doesn't make sense either. Oh no. Oh no. Because it's supposed to be a running total. You don't know. You overwrite the addition or the subtraction, right? Yeah. Because we're not supposed to overwrite the. Yeah. So if it's, we could do it this way. We could also say the new op. That's just a const either, by the way. You could do it this way, operation new op. So we're going to say if the previous operation is multiply, we'll do different things. So if the previous operation is multiply, then we just keep multiplying t. And we say our new op is also going to be operation multiply. If the previous operation is none, then similar thing. And maybe we should do this equals to previous value times current, previous value. So that's if it's none, we're going to update it to multiply. If it's multiply, we're going to keep it multiply. Otherwise, all the other operations, we're going to set t to previous value current times current. And we're going to set our new operation to whatever the previous operation was. Yes, so we're going to preserve addition, subtraction, also preserve multiplication. However, if we are looking at a none operation, we're going to overwrite that with a multiply, and we're also not going to multiply. We're not going to preserve the previous value. If we're seeing a previous multiply operation, then we are going to conserve the previous value. Same thing. The other operations will also conserve the previous value. Okay, it's kind of complicated, but that's how we're going to handle it. I think that works. I think that works. Hoping that works. Now we have a new value for addition and subtraction. In those cases, we're going to overwrite the operation. We're going to apply the operation and overwrite the operation. So addition, we're going to apply it. Subtraction, we're going to apply it. Subtraction, we're going to apply it. And then overwrite these. Yeah, I think that works. We're actually going to have none for operation though. And we'll put 0 in there. That'll get overwritten anyway. If you none multiply t is the previous value, which is 1. Yeah. So then you run into problems again though. No, it doesn't work. The same logic is wrong. No. I think you just keep saying it's just a none. There's no operation up to that point, and so no. T is set to current. I'm sorry, I did this wrong. Yeah. This is what it's supposed to be. Multiply. Yeah, that's what I want. Okay, there we go. All right, that's fine. That's confusing. So the first value, if it's a none, will set a value and say that we're multiplying. There we go. And val just stays at 0. All right, that makes sense. Operation none. This will get overwritten. We don't have to worry about it. We do have to worry about the end though. So if operation is add, excuse me. Add, subtract. Wondering if I need to like include in the scope, include operation here. Maybe I gotta go though. I'm gonna be late. I'm gonna be late, man. What's I saying? So it's not previous type. It's the operation type, previous op. A bit of refactoring here too. Okay. Calculate the new values. Now what's interesting is if the previous type is operation, not previous type, previous op. So previous op could be 4 things, right? If the previous op is the multiply. Also, does this work if we have, can the num be empty? No, can't be empty. So always have at least something in there. All right, so if the previous operation is multiply, which is rare, but can happen. There also could be a none in there as well. If it's none, it'll never be a none. It never finishes with a none. If it's a none, it goes to multiply. If it's multiply, it goes to multiply. So it's either multiply or the other two. So it can never be none. So you don't have to worry about that. But it's just add, subtract, and multiply. Then if it's add, subtract, now it's multiply, that means that everything all the way left to right, like v is meaningless. We'd say new val would actually be previous val, or the rolling value. Previous val is probably not the right way to say it, the right way to express it. So yeah, something like this ought to do it. How are we doing on time? All right, took us an hour. Cannot combine with previous enum declaration specifier. Excuse me? Okay. Number addition in operation. Oh, add, subtract. Yeah, okay. That's my mistake. Oh, it worked. I mean, not worked, but the compiler knows what's going on. Hey, okay. How are we doing on? Now here's the tricky part. What about the very long question? No. I was gonna say there could be parts of this that are quite long. No. The second and the third are both wrong. No. 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 All right, let's check out the second one. I'm thinking of it if we have 1, 2, 3, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, if we have 10 and it's 300 milliseconds, we're fine. That was the problem, is that I don't know how long this will take. We also just have to get the logic right. I have to get going though. I got to go, man. I wasn't supposed to take this long. All right. So it's interesting here. Yeah. So we have to, if we're adding and subtracting, we have to do that. We have to perform the adding and subtracting. So the multiplication at the end, that should actually be happening as you go. And the new value would just be whatever that is. So 2 plus 3 times 2 worked out, but 2 times 3 plus 2 didn't work out. Now, why is that? Maybe we can print, just debug what we got at the end. Strings, S, do that, just see what we got. Should be a bunch. So we did get quite a few. 2 times 3 plus 2 did happen. And then we can also say result v previous op is previous op. I'm not sure what happens if we print it. I think it'll just print the number. Previous val is previous value, and S so we identify this. All right, let's see what happens here. What? Oh, what? No. I think you can convert. Oh no, you can't. Oh, you can. Okay, I was gonna say. Yeah. You can explicitly convert, or yeah, explicitly convert. It doesn't implicitly convert anymore, but you can still explicitly convert. All right. So the previous operation 0 is add, and the previous value is only 2. Ooh, previous value should be 3, not 2. Okay, so that's interesting. So what happens is this operation should be none here. Oh, you know what? I'm actually not sure what to do. previous value just doesn't have an operation. You could do, I'm wondering if it should be current or if it should be the value should be here. Because your new value is add, new operation is add, which it's not going to be, but you do add, you have this new value is what? Whatever value was. And then you add the current value. I'm wondering if this should be current. I don't know. Because if you're multiplying, right, you see none. T is whatever current is. You lose the previous value, don't you? You do. Yes, you do. Yes, you do. Well, I don't know. Should this just be? Yeah, it's because it's 0. The previous value is just 0, and this doesn't. The multiply doesn't use the previous value val. I think it's actually supposed to be val times current. Multiply. That's so confusing. I think it's supposed to be the same. Maybe? I don't know. What happens when we do this? I should be able to think that through, but let's just try it, see what happens. So, still wrong. Okay. Oh. Yeah, because the previous value is 0, right? Yeah, we would want to put this here. I don't think that works correctly, though. I don't know. I have no idea. Okay, I was actually expecting this to work now, but now it doesn't. What? What is going on? What is happening? I gotta go, man. I gots to go. Why? So the problem is we're trying to mix them out. We're trying to mix and match. I have this part of my forehead. I touch it a lot with my fingers, so it gets infected quite often. It gets I get these, like, what do they call that? I forget what skin. It's like acne, sort of like acne. I forget what there's a name for it. Pimples. So the pimples, yeah. So, or not even pimples. Whiteheads. That's really what it is. It's a whitehead. But I don't know. I forget what the name of those are. They're called a whitehead. But I get a blemish. That's what I get. I get a blemish on my head, and I poked it with my glasses. But anyway, so what we're expecting to happen, or we want to happen, is we have no operation, and we're going to multiply. And what's going to happen here, though, is when we do that, we want to accumulate all the multiplicative factors on the left side. And when we want to update that to our previous value here, t. And we'll just keep accumulating. And whatever value was there, I guess we could leave it. Actually, that value itself should be... So what's weird about that is that there is a number on the left side, and that should actually accumulate this t elemental p q r s t u. Let's just say u. We actually want u to be reset to like if you're multiplying, it's just going to be the previous value. We're actually going to ignore that value altogether, whatever the value is. When it comes to addition and subtraction, I guess it would be a 0. See, that's a confusing thing too. That previous value, or that new value, if you're multiplying, this should be, if if the previous operation is multiply, what's weird is when you're adding and subtracting, you want to update val to the previous val. This new val should be basically previous value. If when you actually, if the previous operation was add and subtract, so you actually want to do something more like multiply, none, and then there's add and subtract too. So this gets really confusing. Yeah. You would process the previous two, add and subtract. You don't process the multiplication operation at all, really. You really just update this val to previous val, or now, do you do that later, now? When do you do that? How do you do that? That's so confusing. I don't know what I'm doing anymore with this. I don't know. I think I need to come back to it. My head's starting to spin. Current is what you're currently working with. Sure. How does this work? We want to accumulate the whole total in val, and we want to accumulate a multiplicative term in the previous val. That's what we want. So yeah, this is like a really confusing formulation. I'm pretty sure we can get it to work, but it's definitely not well articulated, and it's way more confusing than it needs to be. Yeah, so we want the multiplicative term that we were accumulating in previous val, and then the additive terms in val. But the problem we can run into is that, let's say, once we complete the multiplicative term, we want to convert that to an additive term and actually add that to our value. That's kind of the issue, and that's when the current operation is an addition or subtraction. We can do that, right? We can, in the addition and subtraction operations, we're going to take whatever this previous value was that we have so far, and we're going to add it to our new value and also add it to whatever val was. Okay, that makes sense. That's fine. This is just val. Really, this is just val plus. Oh no, excuse me. No. So what's tricky about this is we're going to overwrite the operation add or subtract, but we're also going to, if it's an add operation previously or a subtract operation previously, this should actually be the same for all of these, right? So even when we're about to multiply, that should still be the same thing, this new value. So even when we're about to multiply, if there's an add or subtract, then we update to this new value. So we kind of need to combine all these things into one. I think it's also part of the confusion here. So add, subtract, multiply, and it could be none also. It could be another one. So we're not going to have an else. So yeah, we have 4 different possibilities for our previous operation, what it means, what we could end up doing. And we're not going to have a u here. We just have new val, and some t. And we'll come back to what t is supposed to be. So in all cases, if we see add or subtract, then we're going to update our new value. If we see a previous value of multiply, then I'm not sure exactly what we want to do to our new value. We'll come back to that in a moment. If we see a none, then we actually don't necessarily set the operation here. That's key here. we're always, when we multiply, we're always going to say this is operation multiply. Right, so multiply, add, subtract. So we're always going to overwrite the none. But the calculation for this value and this value might change depending on whether the previous operation is multiply or it's none. If it's add or subtract, then we have no problem updating here to. So I guess that's part of the issue too, is that this is actually not true. We're not going to update this to multiply unless this was a none. Then we can update to multiply. So we have a new op, and if it's none, then we'll say it's multiply. Okay. If it's add or subtract though, then we're actually going to keep what it previously was. Yeah. So we can set this to previous op. A little confusing, but we want to persist. It's not the previous operation; it's the previous accumulating operation. So like the previous, we want to accumulate multiplicative terms before applying an addition or a subtraction. We just want to know whether it's an addition or a subtraction. If it's neither of those, then we update that. It's either none or multiply. We update it to none or multiply. So if it's none, that means that there's one element we've processed so far up to this point. If it's multiply, that means there's multiple elements we processed, but we haven't seen an addition or subtraction yet. That's what those should mean. Now, in the case that we've seen so these are always going to be the same, but the case that we've seen we haven't seen an addition or subtraction yet. We've only seen multiplications. If we've seen no multiplications yet, then this tuple, this value, if we haven't seen any multiplications yet, what do we want to do? And we want to multiply. And we have seen a value. So we have some value on the left side. That value is both saved in previous and current. What do we want to do with it? Well, in order to get ready for the next multiplication, we want to update our current. So we don't want to update our current value yet, because what's going to happen later is when there is an addition or subtraction, we're going to update from this, call it previous value position, this rolling value of multiplication. So we actually only want to update t with the new value. So we can use whatever the previous value was, we'll just keep it. And we just want to update t. I think we'll just leave whatever the previous value was. We'll come back to that in a moment too. But t is just going to be previous value times current. Now, if there was no, so the previous value times the current value, I think that's true in every case, because you do have this true in both cases, because you do have at least one value, which is just whatever you processed here will be there, that you can now multiply by what you're looking at now. So this previous value times current. That's fine. We could just set t there. Yeah, so that works in both cases. So you could really just do previous val times current, really no matter what. Now, if you see addition though, then this previous value, so this should be the, I'm actually not sure. This previous value, what do we do now? If you saw addition, but now you're going to multiply, that's confusing. Yeah, you're not going to touch. You're not going to touch the. No. This only applies to when you're actually updating addition and subtraction here. So this is actually kind of separate. I made a mistake. I made a mistake. It's so confusing. It's like kind of quite a lot of logical things going on here. So new process addition, or yeah, process add or sub, something like that. Yeah, that's why. That's why I do it that way. I'll call it just process. By the way, this is like probably a lot more confusing than just creating a create like a calculator that'll just process each string and generate string and just go with that. This doesn't need to be so complicated. Yeah, process and then update. Right. So that actually is really simple, this part. What happens if the operation is not an addition or subtraction on these routines? If it's not at the previous, if we don't see an add or subtract, that means we're gathering multiplicative terms. We're going to add. Yeah, so there's so many different scenarios here. There's four different operations going in, and then 3 different operations that we're going to operate with. So there's 12 different scenarios to go through. That's why I'm getting so confused. But if you come in with an addition or a subtraction, that's going to get processed when you perform an addition or subtraction. But now, what happens if you find an addition and a subtraction, right? Because you're going to replace the previous one. But what if you see you're multiplying things, and then now you see an addition or a subtraction? Well, in that case, we would do what? I think you would take whatever you have in the previous value, and then you would push that into the process value. Right, because at that point, now you're gonna add whatever is on the whatever multiplications you've gotten up to that point. That gets added. You can just add that to your value, set that to your value, and then, excuse me, now you're going to potentially accumulate another multiplicand. So yeah, so pretty much, I think at that point you would, you really would just set current to 1, or set this value to 1. Int start t off at 1, so t would be current. T here is current, and the other scenario is else. Else if previous operation is multiply. You're going to apply your multiplication now, and process is going to be that whatever that value is, and t is going to be set to 1. Yeah, so that's interesting. That's just a temporary variable to kind of help collect my thoughts here. And if it's a none, I think it's really if it's none or multiply, it's gonna be the same deal, right? I think t goes to 0 actually. So what's weird about this is we're gonna have we have some multiplicative term, either none or multiply, right? That's gathered up in the previous value. We're now going to say, okay, we're going to add. We now have an operation of addition, we don't need to process the previous operation of addition, but I think we do move those values over to the current value of things that we've processed. And now you should get sort of another sequence of multiplications, which is going to be your previous values. And then when you add, you're going to add that. If it's potentially adding to the other part that you multiplied. Problem here, though, is do you have 0 or 1 for your... because if you're going to multiply things, you'd want a 1 there to accumulate multiplications. But if you're going to add, if you see another addition, so this actually should be current again, I think. That's also a little confusing, but I think it should be current again. In other words, we don't process the current value yet. Yeah, we don't process the current value here. So in that case, we're fine. We would say in both of these cases, just the current value gets placed there. Even when we see a none or a multiply, if we see a none or a multiply, we just want to update this to whatever the previous value is, so however many things we've multiplied up to that point. And then the current value is going to be overwritten on the previous value in all these cases, when we add or subtract. When you multiply, though, that's when things get kind of complicated, because if there is a previous addition or subtraction operation, I think you still want to get these values. So even when you're going to multiply next, so even if this next value is something that you want to multiply by, it gets a little weird because we don't want to process it yet. Yeah, what happens here? Now it's like a totally different scenario. I have to go though. I really gotta get going. I'm so late. I really gotta go. I think I gotta just make this a part 2 and leave. I think, yeah, because it's not really fair to the folks that they're expecting me. Wow, dude, this is like way harder than I thought it was gonna be. Way more difficult to think through. There's like too many different scenarios. I'm pretty sure I can get it to work, but like, wow. The new value, the new operation, the previous value, the current value. What you want to do is you don't process the multiplication on the spot here, right? So I think in all scenarios this is correct. It's just what's going to happen is you don't do this when the multiplicand that you're operating on now, right? You don't do the same thing. I don't know what value you should keep. I think you don't process the previous value when you're going to multiply. Right? You keep that where it is. Right? It keeps going. The previous operation should stay the same when you multiply, whatever the previous one was. So if it was none or multiply, it would stay, well if the previous was none or multiply, it's going to update to multiply. Doesn't stay the same, but it just changes to multiply if it's none, and changes to multiply if it's multiply. It stays at multiply if it's multiply. This part we don't have to touch, I think. I don't think we need T here either. The thing that's weird is if there's an addition and then we get a multiplication, we actually want to keep that operation, still addition, right? So if it's addition or subtraction or add or subtract, we still want to keep that. If it's multiply or none, none will update to multiply. Multiply we keep multiply. If so just no op. Yeah, the addition and the subtraction. We actually don't process the addition and the subtraction yet. By the way, that actually doesn't happen. No, correct, wrong. For this part, we don't process the addition or subtraction. We keep that new value, whatever it might be, and we just update the previous value with the current value. Part of the problem with this is are we performing the subtraction correctly? That's one issue. This could be wrong. We'll just say to do. That could be wrong. Otherwise, for the you just keep pushing this value forward. I think you don't want to put anything in value if we don't see any operations, right? So when you're looking at none, process is always just going to be updated. Yeah, this is always just going to be updated to this value anyway, so we don't have to worry about that. Same thing happened here. We ignore it. Yeah, if we're at multiply or none, then we don't have to worry about adding or subtracting or multiplying 0. Pretty much in all of these operations, add, subtract, multiply, in this instance, when we're multiplying, all you do is you just update the previous value with the current value, and you don't process anything. Excuse me. And the new value is you just keep passing whatever's in there. And your new op is just whatever that it was, except maybe if, pretty much only if, so I don't know if that's, previous operation is none, just update that to multiply. I have no idea, man. I don't know. I don't know. I'm trying to think it through. Oh, now it works. Now I got it. Trying to think it through and just struggling. Of course. Of course. And the processing at the end is just, you know, if there's an add, you add, subtract, multiply, you just update, same deal. Okay. So these actually do mirror each other, right? Add, subtract, and multiply. Oh, I didn't do any subtraction here. Whoops. The subtraction, you gotta be careful. It's you're actually going to, the previous value is, it's actually a multiplicand on the left side, potentially. So when you subtract, so this is interesting. When you process a subtraction, what does it look like? Addition is fine, it's commutative. If you don't see addition or subtraction, then you just move over the that previous value. And you don't update the previous value when you keep multiplying. So when you add or subtract, we're going right to left, and S is on the left side. So let's say we process a whole bunch of multiplication portions on the left side, and now we have a subtraction. And then we process another multiplication portion. So we have none, we see subtraction, we would push that to the previous value, then we see another set of multiplications. When we see this subtraction, we're going to push it to the left side. Now we're not going to push it to the left side, we're going to push it to the value, and then we have a current value, and then we have a few multiplications, and then we see, right, that'll update the previous value, and now we want to take the value minus the previous value. Yes, so this is actually correct too. This is fine. Okay. So does this work for the other cases? Let's find out. I really gotta go. I'm gonna be so late. Oh, okay. All right, let's try some test cases. So I was gonna write a script to do this, but I don't know. I want to, let's just test some random things. 100, let's do 100, 1,000. I really gotta get going. Say 0. What do we get if we do these things? And I'll be really sad if we TLE on this. I gotta go. Wrong answer. No. No. This is a much harder question than I was expecting to be. So the bottom 1, 2, 3, the bottom 3 are having issues, which are exactly the ones that I just added. Of course. All right. What happened? What happened, man? That's why you run test cases, man. I don't know. Okay, let's do one at a time. Let's do the top one. Or, yeah, top one. Let's try that. Let's do that one. With great difficulty. Oh! Wait, what? That one's fine. Excuse me. Okay. Is it the top one or the bottom one? It's having issues. Oh, the top one's fine. It's the bottom one. It's having issues. Yeah, this one's okay. Wait, what? This is the one that's wrong. The other one I think is fine. Okay. Let's put 10,000 in there. Just double check. So I think the logic is close. I really gotta go though. Yeah, so far we're okay with the logic. What's the target value again? I think it's always no, it could be a negative number or a 0. How about a -1? Let's try that. Let me just text. Oh, okay. Man, programming takes forever. It really does. It's my own fault though. I always do that. I'm always like hoping that it's not gonna take me as much time as it takes. It just takes forever. It takes a long time. Can't think it through in such a short period of time. So apparently there's no way to get 0, I guess, or the ways we're getting 0 doesn't work. I don't know why this would be. Why 0 would be the issue? I don't know. It's sort of like any other number, right? How are these different from each other? Which one's wrong? Are we missing some? Oh, there's a whole bunch of them. Okay, we don't have. Well, I mean, which ones are missing? Which ones do we have? I don't know. What is expected? So 56 plus 4 times 2, 4 times 5. This one is missing? I actually don't know what the whole output is. It doesn't show me. My own program, I'd have to run this in a local editor just to get the output. But even still, I don't know what output's missing or what output's expected. How this is incorrect. What's wrong? Maybe it's not as simple. Maybe it's not that big of a deal. Maybe it's like. No, never mind. I don't know. So you get 6 times 4, 24, plus 7 is 31, minus 30 is 1, plus 4 minus 5. Yeah, that works. And what's this one? Same thing. Plus 12. Do I have plus 12 anywhere in my routines here? Yeah, I have minus 12. Well, apparently this is wrong. It's 24 minus 12 is 12. Minus 5 is 7. Minus 6 is 1. Plus 4 is 5. Minus 5 is 0. That's correct. Is there just something really pathological here that I'm not seeing? 12, 24, minus 4 is 20, minus 15 is 5, minus 6 is negative 1, minus 4 is negative 5, plus 5 is 0. This looks okay. 6 plus 16 is 22, minus 15 is 7, minus 6 is 1, plus 4 is 5, minus 5 is 0. This overall looks okay, man. I don't know. Oh! We can get all the way to the end. Okay. I don't know why we're getting... That's weird. I guess it was just loading. I don't know. Whoa! Oh, man. Okay. Sure. Oh! What? This is my output, has one extra number in there, it just has everything. Oh, I see. Oh, that's why. I know why. It's because the value itself. I see. Let's try that. That's very subtle. That is extremely subtle. Wow. There you go. Okay, I was like, how did I get this wrong, man? I was so close. How did I get it wrong? I see now. I see the problem. I see the problem. Oh no! Now we TLE. We weren't TLEing before. Uh-oh. Uh-oh. Ah, you gotta be kidding me. You gotta be kidding me. Really? Who would have thunk it? Oh no! Now we're just TLE. No! Come on! No! Oh, it was working fine before. We were fine before. Now suddenly we're TLE. Oh, come on, really? No, don't tell me that. Say it ain't so. No. Why? We're doing so well. We were doing so well. Why would it TLE? And when this was a 0, was it still TLE? Hmm. 191. I think it's kind of random. We'll try one more. Oh man, that's tough. Yeah, it's kind of random how long it takes. And it seemed to be okay when I had a few of these test cases. Just one. Just one seemed okay. I don't know how many it's going to test. 586. All right, well, we guess we can't use too many of these. Could throw one more in there, I guess. I suppose that's fair. The last ones are quite long. TLEs. Okay. I don't know if we'll TLE if we try to submit this. A little nervous. Yeah, it looks like you can only handle like one of these large ones at a time. I mean, what are we to do? What are we to do? Oh, that one runs okay. I think this one is kind of brutal with the zeros. The 0, because there's just so many ways to get to 0. I think that might be why it's TLEing. Oh no, got it. 448. Yeah, like sometimes it's okay. I don't know, man. Could try one more. Try this one, 10,000. Maybe there's a boatload of ways to get to 10,000. Yeah, it's kind of a rough one. I don't know. Oh, that worked. All right, we're going for it. I don't know. Probably something wrong. Almost certainly something wrong. I didn't try that many test cases, quite frankly. No! Oh. No. Come on. That's so upsetting. Dude, this is a rough question. Why is this wrong? What do you mean it's wrong? Oh, okay, there we go. If we take the diff, then we can go all the way. What do you mean it's wrong? I probably should have tested more. I didn't think about it. Whoa. So many. So it looks like if you click diff, you can see everything. Okay, that's good to know. So what is incorrect? Oh, look how far it goes. Okay. So these stop at different points, right? If we scroll up. Oh. So my output has a couple extra, huh? I think the problem with my output is that these aren't unique, these strings. Oh no. Oh boy. That makes things even slower. That makes it even slower. Dude, I didn't even think about that. Okay. Is that what I need to do to make this right? Oh man. It was not even. Oh no, it's not correct. Whoa. Where's the diff though? Oh no. Oh. You could have, oh no, my logic is wrong. No, it's not the sets. That's not right. No. You don't need a set. It's not the issue. No, the logic itself is wrong. Oh, dude, that's frustrating. I think we're actually okay to. Oh no, I didn't even think about that. That's upsetting. So many pieces to this puzzle. Yeah, so you can have. It's not that you break here, you just continue. You really just want to see if, so you do it this way, you just say if temp of 0 is equal to 0, you just continue. Skip leading zeros. I think that's all you really need to do. Still wrong. No. No. Oh. And temp is not equal to 0. Yeah, don't skip zeros altogether though. Yeah, there you go. Okay. There's probably some other test case that I didn't think about. There's almost certainly something. I don't have the patience anymore. Ran out of patience. I gotta get going. Oh, of course. Just the test cases themselves now are output 0, 0. How did I get? Wait, what? How did that happen? Excuse me. Wait, what? This doesn't handle that case? I gotta get going, man. I'm so late. Why? Why? Ah! So, oh, I think this has to happen before you add temp because temp gets added on the side. Oh, that's awkward. I think I did this wrong. If current is 0 and temp is not 0, then you'd skip. Is that what we have to do? I'm very confused. How does this work? You don't want to have 0, 0. That's the issue. So why? Oh, yeah. What? If temp is 0, The problem with this is you don't want things like this at the end that are being added. I guess you just check. I don't know. It's fine. I think you just have to check here. I think you just put a check here too. And not temp of 0 is 0, and temp is not equal to 0. That's just so much extra, so much extra stuff just to handle the zeros. It's annoying. That's annoying. Could have just run this before I submitted it too. That would have been good. Okay. There's like 1,009 and 9. A couple of these. Whoa. Or a whole bunch of these. Brother, I'm really late. I don't know. You can't really force like maths and programming and all that. You know, you kind of just have to take what you can get. And if it doesn't take, it takes you too much time, it takes too much time. There's always, oh, come on, man. This is brutal. Dude, this is so hard. I don't know, man. This is like impossible. It's just so many edge cases here. How did that happen? How do you even? Because yeah, I'd have to test for all this. That's the problem. I don't want to go through all these tests. It's just too much effort. Just think of all these different test cases. I'm already the patience. I have patience already. Just want to like go enjoy my time with my friend. I'm already really late. I was hoping to do this in like 30 minutes, but it's just an obnoxiously difficult problem. Why is this? Why is this a thing? So my output here. Oh, it's because you have to convert these to what? The new value is equal to the target value. Target is an integer. My new value is an integer. This should be a long, I think. Actually, that might have something to do with it. Convert this to a long as well. Yeah, that's why. Okay. Brother. Torture. Not torture, but it's really upsetting, really frustrating, because this is like I spent so much time, got 3 wrong answers in a row. I have to get like 30 right answers in a row. Oh, now we TLE. Perfect. That's what I like to see. Just by the way, the reason we're TLEing now, I think, is because we're using longs to do our conversions, which is really annoying. Come on. Really? No. Dude, I'd be really annoyed. Alright, we're just gonna go for it. I don't know. I didn't test the other ones. Probably wrong. It's probably something I missed. There's a million things to miss here. Dude, this is crazy. This is ridiculous. Oh, we TLE'd now. Now we TLE. Now we TLE. Okay. Of course. This is kind of just absurd. This is fine. This works out okay. Just randomly TLEs. I'm upset. We're gonna just keep submitting until we stop TLE. No, I don't know. Dude, why? How close are we? We got through 13 and then we TLE. Well, all that effort to we're like nowhere near success. Let's try again. This is like tormenting myself here. You gotta be kidding me. How far we get this time? No, I could get like nowhere close. You could do something like use an int value here. Should speed things up a little bit. But the problem is it's not going to be correct in some cases. Yeah. It's actually still really taking a lot of time. It's like overflow errors, I guess. Yeah, it takes a while, kind of no matter what. I don't know, man. I don't think we're anywhere close to actually succeeding on this. I'm kind of sad. I'm like really late. A friend invited me over. Oh man. Oh, it's awful. It's awful. I think I want to. Yeah, just like randomly takes half the time. I don't know. What are you supposed to do here? I mean, you could, in theory, do this using like dynamic programming. Oh no, did it? Yeah, we're just TLE now. We're like nowhere near getting the submission. We got through 15 of them. Still have like eight to go through. No, man. No, man. Dude, this is way too hard. This is way too hard. Why? Like, why is it so difficult? So another option, which we could do, which would be a lot faster and probably would be correct, is instead of using a recursive routine, we could rewrite this as a dynamic programming routine. If we do that, I'm pretty sure we'll meet the time limits. We might not still, but I think we will. It's really annoying. I guess the issue is there's a lot of function calls going on here. You don't need all these function calls. So I think it's correct, but also I think this is wrong, by the way. I think that might have something to do with it. Just see if that speeds things up at all. No, not at all. Not even remotely. Yeah, alright. That's disappointing, disappointing. Which, by the way, it looks like this could be added down here too. Could kind of speed things up a little bit. The new op is only for this guy. And yeah, you want to maintain these two. But this part, we could just say, just val. Just new val. You could put process up here. And process here. And that should work fine. Sad. Oh. Yeah, but we're nowhere near getting the right answer though, like in a timely fashion. We have all these tricky test cases to go through too. Yeah, no, we're nowhere near it. Oh, that's disappointing. Yeah, I'm like, dude, yeah, you can't force these things. It's so annoying. It's so frustrating. I really don't like these questions, I have to say. It's not even that I don't like them. It's that I don't like how limited my time is. That's what I don't like. That's what's really frustrating, among other things. Because I want to go do other things. I don't want to spend like 8 hours a day doing these problems, 8 hours for one problem, but it looks like just the difficulty of the problems are such that you're always going to end up spending a lot of time. I think the only thing I can think of for this that we can do, and I really didn't want to do it, but would be to convert this to a dynamic programming solution instead of a recursive solution. Why? Why's it gotta be so hard? It's not even so hard. It's just, well, I think it's fair to say this is a pretty hard question. This was like really involved in terms of the logic and yeah, creating and removing all these tuples, doing all this tuple things is challenging. I think, yeah, I think the dynamic programming version of it would be slightly better, but I don't even know what that's supposed to look like because there isn't really a dynamic programming solution here. Like it's just, I guess it's just for loops instead of a dynamic programming, and you would just refer to your previous values, previous solutions. Trying to think here if there is any value in memoizing this routine. Oh, actually, I didn't think about doing that. Maybe that's what I should do. Hold on a second. Does that matter? It kind of matters. Actually, yeah, memoizing might help. I don't know. We'll explore that later. I'm so late. I told my friend I was going to be there like an hour ago, so hopefully they're not going to be disappointed with me. All right, I'm going to go. Thank you for watching. Talk to you soon. I'm sad. I'm sad. Disappointed in myself. Not really. I'm not that disappointed in myself. I'm just. I guess I shouldn't even tried. I have such a hard time stopping when I get started on something, and it takes a really long time to get through something. So I think that's kind of the problem. It's just I have to kind of know myself a little bit better. That like I know I'm not going to want to stop, and I don't know the solution to the problem. Like these are those problems, those kinds of problems that are like just be really difficult. Otherwise, there'd be no point in me going through them if they weren't that difficult. So, yeah, like if I was already at that point where I could just do these, bang these out 5 minutes each, then like obviously it'd be more predictable. But this is like totally unpredictable. I can't really. I didn't want to waste the time though, but I'd like. Dude, programming is too hard. Programming is too hard. Anyway, all right, I'm gonna go. Thanks for watching. Talk to you soon.